Hey all, welcome back to the part 2 of this video. Today we're going to be concentrating on merit and excellences. Just a quick recap of what we did so far. So we've looked at three things. The first thing is we derived the equation for all the four Korea companies. Second, we went ahead and graphed these four equations on Desmos. And lastly, we did a sample cost calculation. Now, for merit, what they basically wanted to see from you is you being able to design a multi-price model where the cost of delivery is always going to be cheap. In other words, you could be in the future, you could be looking at delivering to more than three supermarkets. And these supermarkets could be anywhere within the distance 0 kilometers all the way to 65 or 70 kilometers within the Auckland radius. So you need to figure out if at any point in time you've got a random distance X where you need to send your goods. Do you know which courier company to choose so that your cost is always minimum? To do this, the first thing you need to be doing is looking at your Desmos graph. Now, to put this in perspectives of numbers, let's start with 0, all right? And I'm again referring only to the x-axis. So between 0 and 20, I see that my red line is below all the other three lines. So that means between the distance 0 and 20 kilometers, AB Transport Light is the cheapest. Now, between 20 and probably 60, that is this region between 20 and 60, I realize that the orange line is actually below all the other three lines. So that means Kiwi Couriers is the cheapest between 20 kilometers and 60 kilometers. Um, if at any point you feel you do not know what the exact point that they're referring to, just go ahead and click on the graph. It gives you the coordinates. So in this case, it is 60, 80. So that means my x is 60. So between 20 and 60 kilometers, it's my Kiwi company, which is the cheapest. And anything beyond 60 kilometers, I've got the green line, which is heavy duty couriers, which works out to be the cheapest. Once I identify these three important parameters, I'm going to go ahead and write them in a form of equations. All right, so the first thing that I'll be doing here is I'll generate a table for this. Let me quickly grab and generate one. All right, so the first heading is going to be equations. The next one is my X value ranges. And the last one is going to be the company name. All right, so we've seen that the first one is the red line, which represents y equals 2.5x plus 10, and this is lower for the values between 0 and 20, and it represents AB Transport Light. Okay, so the next equation was for the orange one, which is y equals 0.5x plus 50, and this was true for the x values between 20 and 60, and this represents Kiwi Couriers. And the last equation was the green one, which was y equals 80, and this is for any ranges of value of x that's greater than 60, and this represents heavy duty couriers. All right, now we've actually got the answer that we need, but we need to put it in context. So if you look at this part, right, if you look at these two columns, that is the range values and the company name, putting these two in meaningful sentences is basically what gives you merit. The best way that I can think of doing this is just try and be more technical, use technical words, and don't try and put elaborate sentences. So what I'll do here is I'll just say that to deliver goods within the radius 0 to so and so, I'll be using this company. to transport goods between distances so and so and so and so, I'm going to be using the next company. So let me go ahead and start writing this up. So I'll write to deliver goods within 20 kilometers, I will choose AB Transport Light. To deliver goods between 20 and 60 kilometers, I'll choose Kiwi Couriers. To deliver goods beyond 60 kilometers, I will always choose heavy duty couriers. I'm so sorry about my spellings. Couriers to keep my transportation charges at minimum. That's it, and that gives me a merit. All right, so now to do the excellence bit. Basically, for excellence, what we're looking at is you coming up with new equation values to suggest a model where you're cheaper than all these three equations put together. Uh, it sounds very complicated, but I think the best way you can remember this is for excellence, all they want you to do is write an m value which is lower than what you've prescribed for the merit part. Example, let's take the first equation. So the first equation, y equals 2.5x plus 10, that is for x values between 0 and 20. If you want to be cheaper than this particular equation, try and change this value 2.5 to be any number below that. For example, I could just say y equals 2x plus 10 for x between 0 and 20. And that's going to be my new pricing strategy. Similarly, I can do that with this one. Y equals 0.5x plus 50. So here my m is 0.5. I can go ahead and make this 0.25. I can just say y equals 0.25x plus 50. And this is going to be my pricing model between 20 and 60 kilometers. And in the last one, the m value is 0. So the only thing that you can actually be playing with is this fixed charge. So instead of charging $80, you could just go ahead and say I'll be charging $75 for any distance beyond 60 kilometers. And this new pricing model, if you can put that in context, that will give you an excellence. So let's go ahead and start doing this. I'll quickly grab and draw a table. And I just need two columns. So the first one's going to be, I would say, new equations and x value ranges. So my new equation, as I said, the first one's going to be y equals 2x plus 10. And I'm going to keep this for distances between 0 and 20. The next suggestion is going to be y equals 0. Let's say I wouldn't go as low as 0.25. I'll just go with 0.4x plus 50, and I'm going to say this is going to be true for ranges between 20 and 60. And the last one, I'm going to be saying my fixed cost is going to be 75. I'm going to be $5 cheaper than heavy duty, and this is going to be true for distances above 60 kilometers. Now, this is just a random guess, so I'm still not sure if this is the right thing or not. To figure out if what I'm suggesting is true, I need to go back to Desmos and put these back in context. So next, just take a look at Desmos. All right, so let's start graphing these new equations. The first equation was y equals 2x plus 10. The other equation was y equals 0.4x plus 50. And the last one was y equals 75. So I've got three new equations. Just to make sure that these three equations do not confuse us in the graph, I'll try and color them as the same. So this one, I'm going to make it black, this black as well, and this is going to be black as well. All right, so this is going to be a new pricing model. So if you take a look at this screen here, um, hopefully this looks better. So I've got this new black pricing model strategies. So let's try and look at our minimums. So I've got an intersection here. Similarly, I've got an intersection here. And this is going to be my new pricing strategy. Now, if you carefully take a look at this graph, you'll kind of understand why I said I only guessed my answer. Now let's take a look at this graph and understand what are the real values we need to be looking at. So when I have my x, which is 0, to my x value, which is 25, this is going to be my new equation range. So it's not going to be true for between 0 and 20, but now it's going to be true for ranges between 0 and 25. And similarly, my next intersection suggests that my new range is not going to be between 20 and 60. Instead, it's going to be between 25 and 62.5 kilometers. And anything beyond 62.5 kilometers, it's going to be true for this equation. So let's go back to our table and rearrange our x ranges. All right, so after looking at Desmos, we realize what these equations are doing to us. So here, the first change is instead of range between 0 and 20, it's now between 0 and 25 kilometers. Similarly, this equation is working out to be cheap between 25 and 62.5 kilometers. And this one's going to be true for any range above 62.5 kilometers. And this is going to be our new suggestion for a pricing model. Now what we need to do is go ahead and put this in terms of context. So we can say that our new pricing strategy can be y equals 2x plus 10 for distance between 0 and 25 kilometers. The next pricing strategy can be y equals, sorry, y equals 0.4x plus 50 for distances between 25 and 62.5 kilometers, and y equals 75 for any distances above 62.5 kilometers. And before I talk about all this, I need to say that I forgot to write a very crucial word here. Our new pricing strategy to be lower than the current market competition. This is something that is very, very important to put in your sentence, because you're trying to make your pricing lower than all your other competitive companies here. And if you can write this bit and just leave it here, that'll give you an excellence. Now, quick update. Is this the only answer that you can get? No, there are infinite number of possibilities. You can actually go ahead and change these numbers infinite number of times and get infinite number of X ranges. As long as they're right and they're graphed correctly, you'll be getting your excellence. All the best for your assessment, guys. See you in the next one.